I've always loved trying to comprehend the universe and the nature of the universe and where it came from and where it's going and where it is at the moment, and try and wrap my head around just the vastness of it and the epicness of it. And it's basically impossible. I love it. And I also love thought experiments, and I guess that is a thought experiment. But I'd like to just put those together today. Actually, yeah, they obviously aren't really mutually exclusive. Now, it's only recently that we've been able to get a clearer view of the actual nature of the universe, and the reality turns out to be a lot more sort of disappointing in a way than sort of a lot of people and I originally sort of imagined it to be. Only a couple of years ago, um, we had multiple models of the universe that has only recently sort of boiled down to more factual predictions. Or not even predictions, sort of, we can factually tell where it's going. And it's not beautiful, it's actually quite disturbing. We're far more sort of insignificant than we originally thought, and the death of the universe is far less poetic than we hoped for. But first, before I tell you how it is, let me tell you what it should be. Let me tell you how the universe should have worked. I'm making a big claim here, obviously, because it's almost like I'm saying that God didn't do a very good job. But I'm being facetious. I'm just trying to say that I could have been, it could have been much more sort of elegant and poetic than it is. So my universe, right, is something of like a cosmic heartbeat. Sort of a great expansion happens, stars form, black holes form, and then galaxies form. And at some point in the expansion of the universe, it starts to slow down. The supermassive black holes in the center of the galaxies devour all the solar systems, over trillions of years, until, if not all matter is sucked up by black holes, well, these supermassive black holes, massive giants, then slowly start to orbit each other, and one black hole swallows another, and quadrillions of years later, or trillions of years later, they all collect into a single gigantic and overwhelming point of gravity that nothing can escape from, creating a sort of original black hole. It's like having mercury in your hand. All the mercury just collects. But so this I would call sort of then a critical mass, when all of the matter in the universe collects back to a original point. That's what I'm trying to say. And then expands into another brand new universe, which creates a cycle, a galactic pulse or heartbeat. I think it's a very beautiful idea. I actually like it very much. Reality, however, doesn't care. We know that the universe could be one of three models: a flat universe, a curved universe, and a closed universe. A closed universe would be totally bent. Imagine flying a plane in one direction and you'll eventually end up at the same place that you started. A curved universe is a universe where you would travel in a direction, say Y, and you'll end up in direction X. Sort of roughly speaking. So it's not closed, but it's also not flat. So obviously you'll be able to tell that a flat universe is where you travel in direction X and always travel in direction X. So it's not flat like a piece of paper. It's it's still XYZ. It's three-dimensional. So it's a bit unnerving, but also exciting that we know that we live in a flat universe. And the rate at which the universe is expanding is actually speeding up. It's not slowing down like one would expect, or it's not poetic at all. The more empty space there is between two attracting gravitational masses, the faster they move away from one another. This basically means that the older the universe becomes, the colder it's gonna get, because the more space in between them. Galaxies will eventually be so far apart that the astronomers that live billions of years, trillions of years into the future, at some place in the universe, will be unable to detect other galaxies apart from perhaps maybe the closest neighbors that are in gravitational sort of lock. This sort of makes us realize that, like, how lucky we are. I'm just going to take a sip of wine. Excuse me. How lucky we are to live sort of in a golden age of the universe. It's, it's fairly new. Not so new that it can't support any life. One, not so old that life will not be able to reach our current observations. It's a very strange way to look at it, but it is also quite beautiful in a way. I'm a bit disappointed that we are not involved in some form of galactic breathing and pulsing and death and birth and a cyclical sort of occurrence, etc. It's also beautiful to know the truth. We are experiencing a very definitive moment in the cosmic history, and we should actually feel humble just appreciate the sheer improbability for you to even be listening to me is. How lucky we are. I wouldn't be able to say it as well as Lawrence Krauss, a theoretical physicist, a very prominent theoretical physicist. So I'm going to read to you two quotes, and I think he captures the beauty of it, actually. So sort of the poeticness of it that I originally said there wasn't, but there is. It's just different. So I hope you find this interesting. It's just two short quotes, 2 paragraphs, and I quote: "In 5 billion years, the expansion of the universe will have progressed to the point where all other galaxies will have receded beyond detection. Indeed, they will be receding faster than the speed of light, so detection will be impossible. Future civilizations will discover science and its laws and never know about other galaxies or the cosmos background radiation. They will inevitably come to the wrong conclusion about the universe. We live in a special time, the only time where we can observationally verify that we live in a special time." That's quite that's quite beautiful, actually. And it's very interesting as well, because we always thought, or I thought, that the speed of light is the cosmic speed limit, but it turns out nothingness is faster, and also gravity, obviously, because that's why you can't see a black hole, because the gravity is so strong that light cannot escape. So maybe gravity can move faster than the speed of light. I don't know. I'm not a mathematician or a physicist. Last quote, and I quote: "A universe without purpose should neither depress us nor suggest that our lives are purposeless. Though an awe-inspiring cosmic history, we find ourselves in this remote planet, in a remote corner of the universe, endowed with intelligence and self-awareness. We should not despair, but should humbly rejoice in making the most of these gifts and celebrate our brief moment in the sun." Unquote. It's profound. In the sort of, I don't want to say like the meaninglessness of it all, or the vastness of it, and how small we are within this great cosmos, and should actually make us feel really good about it, because what are the chances? I mean, we literally cannot fathom it. All right, I think this is a good place to end, guys. Thank you so much for listening. I thought this would be interesting. I hope you think it is as well. I love this sort of stuff. Let me know what you think, and maybe subscribe and like. If I get more listeners, maybe I'll spend a little bit more time in the production of these, because I know it can add good images to look at and all of this. So if you guys want to see some visual stuff, definitely like and subscribe. Otherwise, I'm not going to spend too much time producing these podcasts or videos. All right, take care of yourselves, guys. Cheers.